And it's becoming thousands of them, and it's becoming clear to them that artificial brain, increasingly intelligent machines, are not some distant 22nd century science fiction maybe, but are just a few decades away. In fact, I'll start off the talk after this video. Tell you what IBM is doing. It's just mind-blowing. So, what I'm claiming, this talk will be a mix of the technical side, which I assume a lot of you are engineers, and politics and philosophy and religion. It's such a huge issue. And I believe our global politics this century will be dominated by this issue of should humanity build? I call them Artilects, artificial intellect, artificial minds. And the physicist, and my background is mathematical physics. The physicist in me says potentially these machines could outperform us mentally by just astronomical factors, not like 2 times more intelligent or 10 times, more like a trillion times. You do the math. So it's still not quite mainstream. I mean, it's starting in Australia. Like you're about to see, it's just 5-minute video on ABC television, national. Hungry Beast. I'm a bit out of it. I live in China. Is that a household name? It's a fringy program.
It's a youth demographic, that.
Youth demographic, okay. Well, that's probably not surprising. So, now it's very pithy, it's to the point, very succinct. So you get the gist of what my talk will be about just in 5 minutes. I thought it was so good that I thought I'd start with this. So just sit back, relax, and 5-minute video, and then at the end of it you'll know what I'm going to talk about. And then I'm just going to hit you. I'll hit your brain and I'll hit your gut at the same time. And I'd like to make a little bit of history. So how many people here? About 20, 30? The issue is so new that people, I'm fairly sure if I came a year from now, it'll be like 500 to 1,000. I mean, in America now, they're a couple of years ahead of Australia. You're getting these huge numbers because the issue has got on the cover of Time magazine. The major documentary television programs starting to come out. Like I was on History Channel for January, and there'll be a Discovery Channel documentary specifically on this problem. That Americans call it Singularity. The AIQ, artificial intelligence, shoots up. It's like Singularity. Will be out in November. So, in a year it'll be. My bet is, I used to say 5 years, now I'm thinking probably 3 years. Within 3 years, this issue will be as well known amongst your average educated person as, say, global warming, climate change is today. If you go back 5 years, ask yourself, how aware were you of the climate change issue 5 years ago? You'd have to scratch your head probably, right? But now everybody knows the main argument. So I see similar developments happening just in a few years because there's just so much media coverage. I mean, we have some journalists in this room today, right now. So it's getting out there. Okay, well let's start.
You get so bad.
Does it stay like this? No light. I would like to make a little bit of history. I'd like to hand out some questionnaires. First time it has ever been done. I don't mean Australia, I mean the planet. So, I'll just come to the questionnaire. Could you, during the talk, please, I hope everyone has a pen. If you don't have a pen, you can borrow. Kurzweil and I regularly get in the media locking heads. He is sort of ultra optimistic. Like he talks about nanotechnology. I mean, by 2020, which is only a decade away. I need to start. I've got a good illustration of. Can you raise your hands if you have like an engineering background? Are you mostly engineers? Okay, so you all know about Moore's law. So I'll just give you a personal demonstration of Moore's law that I have in my pocket, literally. Okay, so I have 4 memory sticks here. This one I can't, 5 years ago maybe? Forgetting. 2G, or I'm told you should say gig. Okay, so 2 gig. And then in China about, what, 3-4 years ago, I bought this tiny little red thing, that's 4 gig. And then last time I was in Australia, which was, what, 2 months ago, downtown, I bought an 8G. And then I was in Sydney preparing a new doc on world government, technology. I won't be talking about that today. Writing an outline in collaboration with another mathematical physicist. So I bought on world government. The technology is pushing that. The internet speed doubles every year. So imagine an internet 1 trillion times faster than what we have today in 40 years. It's just mind-boggling. Anyway, and so what, a week ago I bought 16G, and that cost me $30. So I was curious to know what state of the art is in terms of memory sticks. It was 64 gig at $100. Now for $100 you can buy a 2 terabyte massive hard disk. So of course I bought the hard disk. But it gives you an idea of what's coming. So by 2020, if you continue this trend, you will be, technology, engineering, you will be putting 1 bit on 1 atom. Right? That's the trend. So then you can start, well, what I'm talking about, pass out these please. And, you are the first group in the world to do this, right? So please don't be lazy. Make a little effort, because if I can say, the engineers, this is an engineering audience, and X% voted this way and Y% that way, I can probably get a lot of mileage out of that in the media. Right? Because November, Discovery Channel will come out with a major documentary on this, and then who knows? Then professors will be giving talks on this, the textbooks will be written, and the politicians will get involved in it. About 30 pass them around. During the hour, please fill them in. So we're curious to know, is there a correlation between particular views and your sex or your age or your religion or whatever? So I'll start. Oh, so 2 screens. Okay. Can we make it full screen? Okay. So Moore's law, I guess in a sense, Moore's law is the main driver of this whole phenomenon, because by 2020, 1 bit on 1 atom. Actually, this is slightly old. I'm now retired. Well, in a sense, one of the advantages of living in China with American savings, my savings from when I was a professor in America, is that the cost of living is about 7. So I can get across town where I live in China for like 12 cents, 20 miles, 12 cents. I can go and buy a bunch of bananas that cost, $5, $10 here for about 30 cents. So, I can live very, very cheaply in China, live well, except when I have to travel, but then people pay for me, which is nice. So, sorry, I'm still a little jet lagged. I lose my track of thought. And I overslept my alarm, so I should refuel. Let me just drink something. I didn't have any breakfast. That should help. So, 2021 bits per atom. This is the name of the company. So let's start looking at the numbers and then trying to extract some technological and political conclusions. If take something of hand size, say this biscuit, this cookie. So if it's 1 bit per atom, how many atoms in something hand size? Well, you're engineers, so you probably all know about Avogadro's number, right? So it's of the order of a trillion, 6 point whatever, 10 to the 23. So round figures, let's just say a trillion, 10 to the 24. Okay? 10 to the 24 atoms. How fast can an atom switch? Like if you have physics, how fast can an atom change its state? Well, ballpark, right? There's all ballpark order of magnitude numbers. Let's say a femtosecond. Okay? So imagine in the 2020s, nanotechnology, nanotech, is giving us the capacity to nanotech matter so that it's computronium in a sense, right? 1 bit per atom. Switching in femtoseconds, that's 10 to the 24 number of atoms times, let's say, to keep it simple, let's say 10 to the 16 bit flips a second. So this, if it were nanotech as a computer, could perform a bit flip rate of about 10 to the power 40. Okay? 10 to the power 40, which is what? 10,000 trillion bit flips a second. Okay? All right. Now, make the same estimate for the human brain. What is the bit flip or information processing capacity of the human brain? Estimate. Well, you can quickly make an estimate. How many brain cells do we have in our brain? Neurons. New as in the nervous system, and on, like particle, proton, ledon. So the idea of a single unit of computation, the neuron, brain cell. How many do we have in our brain? Anyone know? It's estimated about, let's say 100 billion, 10 to the 11. Okay? And on average, the neuroanatomists will tell you that, well, depending on which part of the brain, if it's back to the cerebellum, it's more like 100,000 connections per neuron. But on average, most of the brain, it's about 10,000. So each neuron connects physically, dendrites, axons, etc., to about 10,000 others. And let's exaggerate a little. And let's say at each connection, or synapse, as they're called, between two neurons, let's say the information passing per second is a maximum a kilohertz. Now that's exaggerating, but again, order of magnitude. So that's 1,000. What's that? 2, 10. Well, it's just one order of magnitude more. So 10 to the 15 number of neurons, 10 to the 4 number of connections per neuron, times 10 to the 1, the number of bits per second per connection. That's 10 to the 16. Right? You add those up. Now, can you remember what I just did for the cookie? 10 to the power 40. And our brain is 10 to the 16. So the physicists in me says that's all I need. Right? All the rest is just details. Humanity, sooner or later, has to make the decision, given these huge numbers, that we have to, we, human beings, the species, we have to make the decision. Will we, in the next few decades, not distant next century science fiction maybe, in the next few decades, in a few minutes I'll tell you what state of the art is today, and it'll blow your mind. Humanity has to decide, do we or not build, and I coined this word, Artilect, in other words, artificial intellect. The Americans tend to call it singularity, but there's a lot of confusion, because singularity also means the historical era in which technology just explodes. So it has several meanings. So I just use the word Artilect, and I'll use that word a lot. So an Artilect is just simply a massively intelligent machine. So when the computing capacity of near future technology just utterly outclasses humanity, the human level, by factors of trillion. That's just the beginning. If you use laptop and it's cold, your laptop will keep you warm. It's generating so much heat. Well, since the 70s, in theoretical computer science, it's been known that in a branch of physics, I guess, called phys-comp, physics of computation, that it is, at a deep physical level, it's possible to actually compute without generating heat, so long as you're computing reversibly. So, well, you're engineers, so I can do this easily and quickly. Take an AND gate, 2 bits in, 1 bit out. Right? Obviously, that's irreversible, right? Because you can't put the same output back in and deterministically get the same original input. Right? You lose a bit. And a guy called Landauer, a phys-comp guy, he said that effectively it's like clearing the memory that generates the heat. But if you're computing reversibly, so if you have the same number of inputs as outputs, then you can take the output and send it backwards in time, in a sense, and get the same input. So long as you can do that, you can still compute. You can have all your logic gates and still compute. So you get the answer that you want. So you can then build up a whole circuit from these reversible components. And then you can imagine a bit stream coming in, it goes through the whole circuitry, you get the answer that you want, and then you just send it back. So you've not wiped out any bits at all. And you've got the answer, you made a copy of that. That may cost you a little bit of energy, but nothing effectively. So you send it back, and you can compute reversibly. Hence no heat, and then if there's no heat generated, so reversible computing, reversible computation, if you want to Google it, it's a huge literature, then you can start having 3-dimensional circuitry. And if you can do that, there's effectively no limit. Right? You can have a computer, an artificial brain, if you like, the size of, there's no limit, right? Planet, let's say an asteroid. So you could go not just a trillion, you could go a trillion. And those huge numbers, that's all classical mechanics. Okay? But we're using classical assumptions. Now, if you go to quantum computing, with the computers that are here, still classical computers, they can only, well, as long as there's one processor, they can only execute one instruction at a time. I'm math, physics, and computing. From China, I was teaching all three. Mathematics, physics, and computing. I was sort of labelled a MPC, Math, Physics, Computing Professor. I was teaching all three, trying to get the Chinese to change the whole structure of the computer science programs. Because when all this stuff really hits, the very nature of computer science is going to shift mightily towards mathematical physics. So computer science as a whole will be upgraded. On average, in terms of professors, the smartest guys on campus, which departments are they in? Well, this has been measured since the 50s, psychologists. Pure math and mathematical physics. In America, for example, the average theoretical physics professor has an IQ of, I'll shock you, 170. If you go to Harvard or Caltech, whatever, they're over 200. They're the real genius. Okay, so as computer science upgrades, as these technologies really come online, and that we have quantum computers. One of my research interests is TQC, topological quantum computing. And the main idea has been around since about a decade now, being used, is store information in topological quantum fields. Now, it's too technical. You need to do, say, master's level in a physics course, physics department, master's level quantum field theory. You need to do about a similar level in topology, in pure math. And then you wed the two, and then you're starting to read the research papers of Ed Witten, heard the name? Probably today's smartest man. He's like the only physicist to have won the Fields Medal Fields medal, sort of like the Nobel Prize of mathematics, harder to get. It's only awarded every 4 years. He's the only physicist to have won the Fields medal. And if you get up, pretty well the research frontier level, mathematics, pure mathematics, especially topology, low-dimensional topology, and theoretical physics have merged. They've merged. They're the same subject. So you'll get seminars of the pure mathematician topologists learning field theory to help their mathematics. And then you get the physicists going to the seminars of the pure mathematicians to learn more abstract mathematics, Lie theory and cohomology and all that topological stuff, so that'll help their physics. They've merged. It's like you have to go back to Newton's time. When Newton did not have the mathematics to solve his physics problems, he just invented the math, like calculus, that little thing, calculus. And, Whitman, everyone who meets him comes away with the impression of, oh God, Shakespeare, super genius. He just invents new mathematics and gets the fields now. It's just amazing. Okay, so when this comes, so if topological quantum computing works, and if you're any physicists in the audience, okay. So condensed matter physics. There's something in that domain. They're called anyons. I'll just quickly. Take 2 slices of silicon, and the gap between, imagine like a sandwich, and the gap between them is so tiny that the wavelength of the electron is larger than the gap. So these electrons, they don't move up or down. In a sense, they're stuck in a 2-dimensional world, sort of flat surface. Now, take that silicon sandwich, if you like, and cool it right down, like to almost 2 millikelvin, really, really cold. And then put a very strong magnetic field this way, then these electrons tend to agglomerate into what we call quasi-particles of about, again, 100 billion of them. There are 100 billion neurons in our brain, of the order of 100 billion stars and galaxies. I'm starting to get very suspicious. Something interesting about 10 to 11? Why does it keep coming up all the time? Okay, so these agglomerations of electrons behave sort of like a particle, so it's called a quasi-particle. And interestingly, and they're called anyons. They have any spin. They're not fermions or bosons. They're not like half-integer spin or full-integer spin. They can take anything in between. That's why they're called any spin, anyons. And interestingly, these anyons have weird properties. Now, you'd think the physics in a 2-dimensional world, the surface of the 2 silicon slices, you'd think the physics would be less interesting because it's confined to 2 dimensions. Less interesting than the 3. No, it's the other way around. The physics is actually richer. And these anyons have weird topological properties. For example, and now I'm going to explain how to compute using these topological ideas. Imagine here's one enyon and here's another, and I just have to throw it at you. But the mathematics, the physics, if you like, all that's important is whether if I swap them this way, so clockwise, or this way, anti-clockwise. That's all that's important. It's a topological property. Now, if I swap them, well, I'll just face on them. So here are the 2 enyons. Now, I'm going to swap them from my perspective, my clockwise. Okay? I just swap them. Now, when you do the mathematics of that, that's like the initial state, and that's the final state. That final state is the same whether I swap like this or I swap like that. Okay? I'll just throw that at you. So it's a kind of topological problem. Now, why is that interesting? Why is it so critical? Well, why today do we not have quantum computers? A quantum computer can outperform today's classical computers by a factor of 2 to the power n. Right? It's exponentially more powerful and especially for simulations and so forth, than a classical computer, which does one thing at a time. So if you have, imagine n of these anyons, like in a row, like a register of anyons, that potentially, if that computer, like that quantum computer, it could outperform a classical computer by a factor 2 to power n. So if n is large, then 2 to the n is just enormous. So if we get quantum computers that can scale up realistically and robustly and well, with large n, then the world will never be the same. Everything will change. Physics obviously will revolutionize chemistry, biology, economics, technology, politics, right? So one of my research interests is this T, topological quantum computing. So now remember the math, physics, if you like, whether you do it, swap it that way, just a short path, or this way, is path independent. Doesn't matter. The only thing that matters is that topological property. Did you swap clockwise or anti-clockwise? That's all that matters. Okay, so why do we not have quantum computers today? Because they are so fragile. They are so susceptible to noise. But if you imagine this is an electron, and it's a quantum computer, right? So quantum computing is about putting information on quantum systems. It's taking quantum phenomena from quantum mechanics and using that phenomena to compute with quantum computing. So if you've got a bit of a physics background, the two essential properties of quantum mechanics that get used to compute with are superposition of quantum state. You're a technical audience, right? So you've all done some quantum mechanics. Are you an engineer? Yes? No? Good. Well, doesn't matter. If you haven't, doesn't matter. But the two essential properties in quantum mechanics that it's used to compute with are superposition. You have one state, you have another state, you just add them. And non-locality, or same thing, just different word, entanglement, which is probably the weirdest phenomenon in all of physics. Like two things interact and then they separate, and you do something on this one, at one end of the universe, and then instantly in zero time, underlined, zero time, what you did here influences what happens here, on the other side of the universe. Right? So our concepts of space and time just get revolutionized. And even today, since the 30s when it was first thought about, Schrödinger, famous Schrödinger equation, people still haven't really digested the implications of entanglement. Yet quantum computing uses it, right? And there are quantum computers. They exist since I think 98 or so. But the big problem is noise. So if this is, say, an electron, and you're storing information on the electron by its spin, let's say. So if it's spinning this way, I'm keeping things simple. If you're spinning this way, let that be a zero, represent a zero. Spinning the other way, let that represent a 1. But if that's an electron, it's very vulnerable. Now imagine this is some other atom or something, it gets close to it and disturbs it, changes its state, right? So you lose the information. Like, I won't actually do it, but often when I have more time, I'll take off my shoe and then I'll use the shoelace to represent information. I've got one. You'll never forget. I mean, this is a professor's teacher. Okay. All right, and usually I'm going to use my shoelace to represent information topologically and non-topologically. So I'll start with non-topological. I'm going to represent one bit by the angle of the shoelace. That's a 0 and that's a 1. Okay? Just a simple angle of the shoelace. Now along comes some noise. Oh, disturbed the state, lost the information. Okay? It is a crude analogy, but you'll remember it. Okay, now I'm going to store the information topologically. I'm going to store it in the form of a simple knot, K-N-O-T. Right? Now, you know there's two ways I can do this. I can do this simple knot. I can go that way, I can go that way. Two different, very simple knots. Okay, I'll do it. Now, last time I did this, I could not undo the knot. So it was incredibly robust. Okay, now comes, I don't know, that's either a 0 or 1, whatever, just a convention. But I tie the knot, and then along comes some noise, whoop, but the knot's still there. Okay? That's the essential idea of topological quantum computing. You store information in something called topological quantum fields. Okay? That's the essence. Like, I guess topology is not taught in engineering. Take a donut, an ordinary donut with a hole in the middle. Okay? And imagine it's not made of flour, it's made of soft rubber. And then, so you take this rubber donut and you twist it and you stretch it and you squash it, and all the angles and lengths, they all change, right? But something about that donut has remained unchanged. It's constant. Or as the topologists say, it's some property of that rubber donut is topologically invariant. It has not changed. Common sense. What has not changed? Some property of that rubber donut. What has not changed?
The hole.
The hole. Right, there's still one hole. So that's an example. The number of holes in topology, that's called genus, G-E-N-U-S, which is a fancy name for number of holes. That doesn't change. So if you can have quantum fields from like master's level quantum mechanics, if somehow you can put information into these topological properties of these topological quantum fields, then you may get robustness. Now, in physics, so far, the only known phenomenon in the lab, in the real world, that has these weird topological properties are these anyons. Well, maybe I'm a little out of date. I haven't kept up the last year or two. But at the moment, let's see, 2005, the first enyon was actually discovered. From 2002, let me show you how you compute. So the mathematics of how to compute topologically using these anyons has been known, right? So the math is there, 2002. The actual physical product, how to implement it in hardware. So these enyon chips, first enyons with these properties discovered 2005. Okay? So it's all very recent. But the particular enyon that was discovered was not quite computationally universal. That means you can't compute everything. Right? There's some things it could not compute. So today a race is on. We have various labs around the world working in enyon physics, condensed matter, specifically the fractional quantum Hall effect. It's a big branch of condensed matter physics. Physics department. So a race is on all around the world with various labs to try to find other enyons, because there are many of them, and then prove that the particular one they find has these topological properties and sufficient that you can compute with them. And the first lab to do that will get a Nobel Prize. Right? When you think about it, quantum computing, scalable, robust quantum computing, 2 to the n. Yes. And all that goes into the Artilect, right? In a sense, you could say, all roads, or technological roads, science, and they're all leading to the Artilect. Like analogy, all roads lead to Rome. Right? All nanotech, robotics, artificial intelligence, physics, they're all, in a sense, converging to this enormous possibility. Okay, so I've given you quite a bit about the enabling technology because you're a technical audience. Now I want to shift a bit. I want to shift away from technology into politics because it's going to have enormous repercussions, as you can imagine. So where are we now? Okay, let's go to 3, the species dominance debate. Now I promised I'd hit you with state of the art. Did you notice in the news just a few days ago, a guy, again, IBM, so IBM 97, World Chess Champion, 2011, earlier this year, Jeopardy, a quiz show, natural language processing. A quiz show? It beat the two best humans. So that just blew Americans away. It was major news. A computer called Watson. Now, at first I thought, oh, you mean the assistant of Sherlock? No. It's the name of the founder of the company, IBM. Watson. So this supercomputer could understand language sufficiently to actually win against the human best. I mean, think about it. Right? Today, so within a few years, this technology will be in your PCs, on your desktop. You'll be having conversations. It's not a question of technology anymore. The know-how is there today. It's now just a question of economics. Right? How cheaply can so if it's not economic today, we only have to wait a few more doublings. Right? Moore's law will give it to us. So within a few years, we will all be having conversations with our computers. Right? So 3. Now let's go into the 2020s. I've spoken with some Korean techie guys, senior people, and they're saying they've persuaded the South Korean government to put an intelligent, useful home robot in more or less every South Korean household by 2020, within a decade. And Bill Gates, everyone knows the name Bill Gates, he's on record. He says by 2030, just a mere 2 decades away, the home robot industry will be worth trillions, literally trillions of dollars a year. I mean, ask yourself, take it seriously. Ask yourself, how much money would you be prepared to pay, especially for housewives, for a genuinely intelligent, useful home robot that could walk the dog, babysit the kids, entertain you, sex you, tell you jokes, be cynical, sense of humor, rich vocabulary, infinite knowledge? How much would you pay? Well, I've done this. Most people tend to say, oh, maybe more than a car. A house would be more expensive, but you have to have a house. That's probably your top expense. But the next one might be home robots. So within 20 years, this will be a major industry. It'll be the next Google or Microsoft, right? The home robot industry. I'm trying to persuade the Chinese government to invest heavily in this stuff, to create, I call it CABA, C-A-B-A. So Chinese, A-B is just artificial brain, but it's the final A that's interesting. So Chinese artificial brain, the final A is administration. Can you guess what that means? I'll give you an analogy, give you a hint. NASA. National Aeronautic and Space Administration. So when you hear that word administration, what are you talking about? You're talking about tens of thousands of engineers and scientists, and whose job would not be space, not designing rockets and exploring the planets, but their job would be to design ABs, artificial brains, for the Chinese artificial brain industry. So you can imagine then a NAVA, equivalent to NASA, a JAVA, Japan, EBA, Europe, CABA with a K, Korea. All the major tech countries, they will all have to do this because it will be a major industry coming. Now, are you aware, it was in the news, I guess, Chinese tend to screw things up in some ways, and jaw-dropping in capacities and others. Just 3-4 years ago, there was not a single kilometre of high-speed rail track in China. And today, there's now more high-speed rail track than not just the rest of Europe, that was true a year ago, but today, than the rest of the world. And and they had, it was in the news, did you hear it? It was, recent. They did too fast and they were crashing. And the Chinese today are developing a high-speed train that can travel at 500 kilometers an hour. Like my sister and her husband, I've seen videos. They were videoing the speedometer of the train, and it went over 400 kilometers an hour. That's routine. You're just ordinary, daily passengers. So when the Chinese government decides to do something, they're a brutal dictatorial state. If you're Chinese and you say, "Oh, down with the government," and they'll pop you in a Lao guy, which is like a gulag, slave labor camp for political prisoners, somewhere between, estimates are between 500,000 and about 2 million political prisoners in China. So it's a horrible regime. But when they decide to do something, it's just mind-boggling what they can actually do. And the high-speed train is a classic example. So I'm trying to persuade them and others to set up a cabinet. And then you'll get all the competition between the major high-tech countries. And, if you think about it, enormous momentum. Economic momentum. How could you stop such tremendous momentum? And then you get the political rivalry. Because, China's obviously on the way up. That's why I live there. I'm in my 60s. My birthday today. When you still love me, when you still feed me, when I'm to the 6th today. So, I'm healthy. I exercise, I take multivitamins. My father's 92, nothing wrong with him. So I hope to live another 30 years. That's equal to it's my second half of the career. So I don't know the word. I've been looking around for a word. In America now, the boomers, baby boomers, are now retiring in mass numbers, huge numbers. But almost individually, they're saying, hey, I'm healthy. I've got another 10, 20, maybe 30 years left. I'm not going to just walk or go to a corner and quietly die. So they start a new career. That's what I've done. I switched, we've been officially retired for a year. And I've just switched careers. I've just taken up a new career. So I call it ARC-ing, A-R-C, after retirement career. So I label myself an ARCer. I'm an ARCer. So my new career is, I don't run a lab anymore. I just sit quietly in a corner, and I'm now just doing mathematical physics like crazy. Stay up all night because I'm free. So I go to bed at 8 a.m. and I just do math and physics because I'm contracted to write books on TQC, and another fascination is the possibility of a femto tech. Does that sort of penetrate what you could do with that? I guess, there are various fathers, but what time do I need to finish? I need to watch the time.
Maybe 5 more minutes.
Oh my God. No, I think it's sure. You got the essence.
Because I retired at 12:30.
To 12:30?
Well, that's what I thought.
Oh, fine, all right.
I know, but I leave it to the methods assembly.
I need to go like 12, 5.
You or, the room?
Other people, no. I guess the room's free.
Till 12:30?
I presume so.
Okay, all right. So, femtotech, what's that? Nanotech is nanometer scale technology. And anything nano is just a billion, thousandth of a minute. So a nanometer is the size of molecules, and a femtometer is 1,000,000 times smaller. So if molecules are the size of 10 to the minus 9 of a meter, what's a femtometer? 1,000,000 times smaller. That's the size of a nucleon, like a proton or a neutron or a quark. It's like 3 quarks inside a proton. So is it possible by just sniffing around all this phenomena, nuclear physics and particle physics and field theory and blah, blah, blah. Is it possible to find ways, phenomena at that very low level of physics, that you could actually manipulate as engineers, right, a technology? And if that's possible, a femtotech could outperform nanotech by a factor of 1 trillion. Right? The density this way, 1 million times denser. That way, also 1 million. That way, 1 million. So 1 million cubed. And because your components are closer together by a factor of 1 million, the signaling speed between the two components is 1 million times faster. So your total performance of a femtotech substance would be 1 million to the fourth. Density 3, power of 3, and the speed also 1 million times faster. So 1 million, that's 1 trillion twice. So 1 trillion times. So that's, now that I'm free, I don't have to worry about grants. I'm fed up writing for research money. Free from all that, thank God. So now I'm just arcing, and because of American savings and Chinese prices, I can afford to retire early. All right, species dominance.
Sorry. Before we go on to politics,
Yes.
can I ask that?
Yes.
So how could Moore's law be driving phenomenon?
Because of Moore's law is impacting heavily on neuroscience. So the neuroscience guys, I didn't say that, but there are like two preconditions to get all this stuff. One is the computing capacity. You have to have that. It's only now that, like today's supercomputers are reaching the 10 to the 16 bits per second, right? It's the equivalent of the human brain. So our supercomputers today are more or less equal to our bit processing rate of the human brain. But of course that's necessary but not sufficient. So how do you make it sufficient? What else do you need?
Yeah, I hope that's exactly what you should have said. I think. It's necessary but not sufficient.
Okay, well there's so many things these things are. So the neuroscience guys today are using...
But you just spent an hour talking about densities of information. I mean, it seems a waste of time in a way. It's only a necessary but not a sufficient condition for what you're just about to go on to talk about.
All right, but there's so many factors, and I haven't even touched the political...
Just make a suggestion. How about you want to talk for another, say, 15 minutes? And we have 15 minutes to debate a question. I think that might be a good use of the time.
All right, well, how about compromise? Do 5 minutes on politics, because the politics is what I'm really interested in.
Yeah.
Okay, so in the 2020s, 2030s, people are buying their home robots, and every year or two they update the model. Right? They become increasingly intelligent. So if this is human intelligence level, and this is robot intelligence level, state of the art, as the years pass, so in the 2020s, 2030s, that IQ gap between human level and machine level, that gap's going to close. And then the species dominance debate will start raging. People will see it as the dominant issue of our time, political issue of our time. And then people start taking sides, giving them labels, because new ideologies, new political movements. So the people who want to build these artilects label them cosmids based on the word cosmos, because there's a whole universe out there. Right? These creatures will be immortal, outperform us trillions of times. So that would be godlike. So you can imagine almost a kind of new religion being formed, based on science, but with the same sense of awe and destiny and purpose and so on. So a kind of new science-based quasi-religion for the cosmism of the ideology. The people who are opposed, who are terrified at becoming number 2 species, because when these creatures come into being in the next few decades, if humanity decides to do that, because it's not, like I say, it's not next century. It's within our lifetime. And you guys are quite young. So you will see this debate raging within a decade or less. And amongst the intellectuals, it's starting already. And amongst the techies, especially in America, it's raging now. Right? There are movements. Go to the web. If you want to Google something and then get into this debate, just remember the keyword Singularity, or just Singularity, that'd be enough, or Singularity Institute, and then you can see all the videos and debates and so forth. Okay, so just quickly now, some of the arguments of the cosmists. You'd be building gods, trillions and trillions of times above us. They're like the next major rung in evolution. Humanity now is at a historic epoch. Do we freeze the state of evolution at our current puny human level when we could build Artilect? The big picture argument. Humans, we're genetically engineered to strive, like climb Mount Everest and so on. How do you stop it? The momentum arguments I gave you, how do you stop the economics? How do you stop the political rivalry between China and America in the 2030s or so, if China doesn't democratize within a decade or so? Now the Terrans, what's their point of view? Basically, fear. Right? If we become number 2 species, we're then subject to what the Artilects want. And a lot of people, believe me, from first-hand experience, a lot of people don't want that to happen. And when push really comes to shove, as that IQ gap closes, they say they will go to war. They would argue it's better to kill off a few million cosmists for the sake of the survival of the billions of humans. But there's a third option, the so-called cyborg or cyborgid. Some people argue, well, this confrontation between the cosmists, the pro-Artilect people, and the Terrans, the anti-Artilect people, could be avoided. You just go around the problem simply by effectively doing this. So human beings themselves become Artilects. So you just upgrade yourself and become, in a sense, a god yourself. So there's third of them. So 8, how does this? Now, this is my view. I see a major war coming. I got, in my age, I got conscripted to go to Vietnam. When I was living in Australia. 18 years old, didn't even know the vote. Absolutely bitter hatred of the government, treating me like a piece of meat, just to serve their politicized. So I see, as the debate really starts raging. In fact, someone shocked me just a few days ago. Some anti-nanotech organization in Mexico is repeating the kind of thing that the Unabomber did in America, sending parcel bombs to professors in universities in nanotech. Actually, it was some guard man, security man, who opened it up, and he was damaged, not the professor. But as this species dominance debate heats up, you'll get the sabotages and the assassinations, and people will take sides, political parties will be formed, because this is a major issue. Like 19th, 20th centuries, the major issues then were democracy, socialism. So the dominant issues label the parties. So there'll be probably new political parties formed over this dominating issue, which will dominate our global politics this century. So you'll have pro-Artilect parties and anti-Artilect parties and so forth. Now the really sad thing, if you go to point 9...
Sorry to drop again. You said this century. I mean,
decades.
That's based on this Moore's argument that we'll have double information density, and that's the driving factor. I thought you just already conceded that it's a necessary but not sufficient condition. So your figure this century seems a little...
You've got other phenomena. For example, the internet speed keeps doubling every year, not 18 months. So I label that BRAD, bit rate annual doubling. And the physicist in me says there's effectively no limit to how tiny the substrate can be that you can put information on. You need some physical substrate. So that that doubling will probably continue for many decades. So 2 to whatever, 30 years.
Maybe that's doing the first hour, but necessary but not sufficient condition. Because the nematode worm with only 302 neurons is still a mystery.
Yeah, but so you talk to the neuroscience guys, and they're saying neuroscience is also being revolutionized. Like, okay, I'll give a pitch now.
I'm a
IBM.
scientist, so you've underestimated the information content by about between 20 and 30 orders of magnitude.
Well, it depends on your theories. Anyway, look.
Just when you put figures like 100 years.
Look, let me say this. Imagine who I am, right? Your arguments because I've lived in 7 countries. I'm very familiar with what's going on in the US, and your arguments are about 5 years behind. I'm being blunt, but it's a fact. Okay? There's a whole movement of very, very bright guys saying all this stuff's coming in the US. They're taking it very seriously. It got on the cover of Time magazine. Okay. So
that's the first time in a science talk I've heard it got on the cover of Time magazine as an argument.
to Americans it means a lot, believe me.
Okay, but let's just accept the premise
Let's be superficial here, okay?
and go with the political.
So look at 9. If you draw a graph of, say, on the vertical axis, the number of people killed in major wars, and on the horizontal axis, time in years. You go back, say, early 19th century. So the Napoleonic Wars. On the famous Battle of Waterloo, one day. What was the scale of industrialized, in those days, industrialized killing? Think about 70,000 soldiers died that one critical day of Battle of Waterloo. American Civil War. Technology then was rifled, spiraled rifles, far more accurate. And you got hit by a bullet, you got this size, you take your arm off. So the American scale killing in then, so mid-19th century, was about 500,000. Now if you go to China at the same time was the Taiping Rebellion, where the Qing dynasty almost fell, 20 million killed. Most people don't know about this. Okay, First World War, so again new technology, machine guns, gas, shells, about, again, 20 million. Second World War, depending on how you define it, for the Chinese started in 37 when the Japs invaded. Europe, 39 when Nazis invaded Poland, and the Americans, 41, and again the Japs bombed Pearl Harbor. So somewhere between 50 and 100 million. Last century, the total casualty rate, people dying for political reasons, wars, purges, genocide, Holocaust, 200 to 300 million people. It was the bloodiest century in history. So if there's a major war later this century over this issue, there's so much at stake here, right? We're not talking about the survival of a country. Like when Stalin was fighting for his life at Stalingrad against the Nazis. Fighting for his life. He knew if that city fell, the Nazis would get all of Russia, all the oil fields. Right? You just put the whole country in that one city, and then every time every time he moved from the west towards Berlin, every major East European city he captured, it cost sacrificing about 100,000 young Russian lives. But he's prepared to do that for the sake of the survival of the country. This time we're talking about the survival of the species. Right? So the passion level, the stake, has never been so high. So when this debate really starts raging, believe me, well, it's starting already. We're seeing it in the US amongst the intellectuals. It's raging already, people taking sides. But with 21st century technology, probably nanotech-based, the power of the weaponry will be so much greater. So if there's a major war, we're not talking casualties in the millions or hundreds of millions. We're talking billions. That seems a reasonable assumption. So I just talk about gigadeaths. So it's very, very scary. So on the one hand, it's magnificent because we could get rid of disease, aging. We could make out with nanotech. We could make ourselves immortal. We have tiny little computers that detect aging cells and reprogram them. There's a whole movement there, especially the US where it's all being largely pioneered. Now, often in these talks I'll ask people to vote, and typically, if I keep the vote question simple, do you think humanity should build these artifacts or should not build them? And typically the answer is about 50-50. It's a very divisive issue. Now, have you been filling in the form as well? So, in the past, I've just kept it simple. It's a simple question because it's easily done. So, this is the first time an actual survey. And in the near future, these surveys will become more and more common as the issue heats up, as the issue goes mainstream. which it hasn't quite done yet, but soon. Well, I can stop there. We have Q&A. We have 20 minutes.
So, this is something that I've actually spent a lot of time on over the past years. I've written a novel about physical technology, a war between the Artilect and the topological.
Between the Artilect and the science.
I think many of the questions here are sort of not very well defined. Like the question.
Yeah, I'm not a sociologist, so.
Question for you: do you think humanity should allow cyborgs to exist for non-intelligent thinking? They already exist. So, by any reasonable definition of intelligence, a human with a pencil and paper is more intelligent than a human without a pencil and paper. By any reasonable.
That's missing the point.
No. I think it is the point. A human with a pencil and paper. The pencil and paper is effectively a prosthetic brain. It improves your memorization. It improves your ability on almost any reasonable measure of intelligence. Similarly, a person with...
That's nitpicking. I'm talking about technology where you add to your brain and suddenly you can learn Chinese like in a second or you're a trillion times smarter. That's what I'm talking about.
I'm getting that. So that's a pretty trivial form of cyborg. Then for a person...
I have this, therefore I'm a cyborg.
Yeah, a person with access to the internet will score a lot higher on any measure of intelligence than a person without access to this huge amount of human knowledge. A person with a telephone who can call up a friend will score higher on any measure of intelligence than a person without access. So there are all these things that are slowly building up effective human intelligence. A modern human with the knowledge of all of humanity before us is vastly more able to do.
What's your point?
The point is, we're not going to suddenly say, oh, put this in, you're a cyborg. We're going to slowly build up to that point.
Yes, agreed.
And people won't ban pens and paper because that's absurd. And it's not going to be we can draw a line in the sand here. It's going to be a gradual building up, and
so you're sort of saying like the frog in the water. When the water's cold and you boil it slowly, it won't jump out. It'll cook.
That sort of thing. So the concept of cyborgs exist but more intelligent humans. We already exist. We've got better nutrition than we had 2 millennia ago.
But what's all this? Are you saying? Are you leading into an argument because of the continuity of the small changes? Therefore, it's going to happen. We can't avoid it. And we can't stop it. What's your point?
Well, you can't answer yes or no to question 3.
Oh,
this is the point.
Okay.
Similarly, when you say.
Well, this is the first effort, and I'm not a professional sociologist. I don't know how to write questionnaires. So this can be done better by a professional. But it's the first time we're trying to get the issue out there, and this is the first time ever, like on the planet. So, you expect it to be amateurish. I'm not a professional.
I've had many discussions like this before. It's not the first time.
Questionnaire.
Similarly, discussion about artificial intelligence, comparing it to human intelligence levels. Computers are currently extraordinarily fast compared to humans. They have access to this enormous amount of information, and we don't yet have good enough software to make them intelligent in the sense that we are. So, assuming that comes in the future, it's unlikely to suddenly go from nothing to there. So it'll be probably a slow building up, at which point the computers will be a lot faster and with access to a lot more knowledge than us. But and it's not clear how you compare the machine intelligence that's better, more intelligent than us in some ways, less in other ways to human intelligence. So again, sort of